Good afternoon to Europe and good morning to the Americas. Thank you very much for joining us. And today the topic of our webinar will be the COVAS. And I actually chose this topic because I'm very, very excited about this device. In contrary to many of our thermal devices that you may or may not know, this is an accessory to any of these devices, and it uses a different purpose. So in our webinar today, we will talk about how the COVAS works and also talk a little bit about participant-related factors and how the COVAS can contribute to that. The use of the COVAS in different paradigms like the offset analgesia, tonic pain ratings, itch ratings, and condition pain modulation, and whether the precision outcome that the COVAS offers gives us an edge in repeatability. I would like to also introduce you to a participant or patient-controlled intensity that the COVAS can help you with. And then we will talk a little bit about data analysis. At the end, you get you will be able to ask a few questions by typing them in, and if we don't get to them, we will be happy to answer you via email. So stay tuned. So pain rating is our bread and butter when we talk about the business of pain and the business of pain pain research or even use of pain ratings in the clinic. And classically, we have found several methods to ask our patient or participant to rate pain. And of course, this is a very complex action that we ask for from our participant or from our patient, because as we know, pain is an experience, it's multifactorial, it's multidimensional, and now the patient has to express it in numbers, for instance, here on the NRS, or in a stripe that you put on a scale of 100 millimeters. But what if we want the patient to continuously rate the pain, or to rate the pain along a longer period of time? Then we have a timing issue. And also asking the patient to rate pain in numbers, for instance, how much does it hurt from 0 to 10, and 0 is no pain at all, and 10 is maximum pain that you can imagine. We ask in this our patient to translate their experience to numbers and verbalize that, and that's quite a cognitive load. The COVAS can currently be used with all of our thermal products, by the way. In the past, you could only use the COVAS with the TSA or with a pathway. They had their own COVAS. Today, there is the COVAS USB, and it can be used with all the devices that go along with the MMS. So how does this device work? This is a computerized visual analog scale, and it works like the visual analog scale on a 100 millimeter scale. It works with a potentiometer, and the ratings are visible during the test as well as in the Excel results, and I'll show you several examples of that later on. Before we use it, we calibrate it usually. Let's do that. Let's show me a small video. We go into settings and hardware settings. And then we go to COVAS calibration. It's a very easy thing to do. You just do it in the morning when you start to set up. Now we are asked to move the lever to the left. And then we're asked to move the lever to the right. And then we are clicking next and finished. And then we should be done. Then we're done. We're going out of hardware settings, and we'll always have to pass self-test for those that know our devices and use them. So the COVAS can help us with specifically with participant-related factors. And as I already mentioned, when we ask the participant to translate their pain, there is a cognitive load. It takes maybe a somewhat away from the attention that they have on their sensations, and now they have to verbalize it. And this also has an effect on how fast the participant will be able to rate their pain. So if you say, how much does it hurt right now? They go like, um, yeah, it's 60. But before it was more painful. Well, so this is a timing issue, and it will be very hard for you to have repetitive results between participants or within the same participant in the same paradigm, as every time it takes them a different timing to answer your questions of how much pain they are perceiving. Another thing with the COVAS is that the participant examiner interaction can be limited by using the COVAS, and even though the interaction, we try to standardize it as much as possible, there are factors that are beyond our a circle of influence. For instance, the gender of the examiner versus the gender of the participant, or the race, and we know that these factors, or how empathetic I feel that the examiner is towards me. These factors we know can introduce noise to our data. So in this also, the COVAS can be a tool in the sense that now the examiner is not asking the participant how much everything hurts, and the participant is interacting with the COVAS instead of with a person who can maybe give nonverbal cues, who I have feelings or non-feelings, or I feel that they are trustworthy or not trustworthy, and these things matter in pain ratings. So let's go into what type of paradigms we can use when using the COVAS. So one nice study that I would like to introduce to you from 2 years ago by Daggett, and this is out of Sherbrooke. They did a tonic stimulus, and they did this paradigm in two different groups, 26 participants all in all. Half of them were young, around 28 years old, and half of them were old, around 67 years old. And they did also a very nice thing regarding pain threshold and pain tolerance threshold, because for that they also used the COVAS. They didn't use the limits that we know, in the sense that we have a temperature goes up and the participant is pressing the button and then the temperature stops, goes down, and we do that several times and it takes a while. They used the COVAS. So the first moment that the person is moving the COVAS away from the 0 point mark, that was the pain threshold. And the first moment that as soon as the participant arrived at the 100 point mark, that was the pain tolerance. And that's how they used the calibration. They knew the pain threshold, pain tolerance threshold, and the calibration for pain 50. And in this, when they used the tonic pain stimulus, they used the pain 50 temperature. And the nice thing that they found using the COVAS is that there was a difference between younger and older participants, in the sense that younger participants had a first peak. Incidentally, when the temperature goes up, they had the first peak, and then the peak went down, and then they flattened out. While with an older participant group, there was no first peak. And this is, I think, an interesting and nice finding. And this is also shows where the COVAS can be instrumental, because this is something that is very, very much timing related. This first peak only happened in the first 30 seconds. And, and when you use the COVAS, you can really get a graph of what was going on. Another nice study, and this is a study out of Brazil, where they used in a study 2 different bleaching agents, and they tested the effect on dental sensitivity, specifically to cold stimuli. And very common in this type of studies and this type of practice is just to ask the participant how much does it hurt over a period of time, and is there a spontaneous pain, or is there provoked pain? And what I liked about this paper is that they actually used QST to validate the results of the study. And home dental bleaching agents have reactive forms of oxygens that are used. And one of the side effects is that the agent activates a TRPA1 ion channel, which can cause an increase in sensitivity to the bleached teeth. And in latest years, potassium oxalate has been added to these bleaching agents in order to reduce the sensitivity. So, and now they're trying to validate whether this potassium oxalate helps, yes or no. And they had people have bleaching their teeth on the same on molars of different sides of their mouth, and had them tested using tonic cold stimuli at 0 degrees, and use the COVAS to rate their pain. And as we can see, this is a strong result, in the sense that they did not find significant differences between the bleaching agent that used potassium oxalate and the bleaching agent that didn't use potassium oxalate. So this is a nice way to introduce QST into dentistry, but also to show that the COVAS can be instrumental in finding out whether something works or does not work. I want to introduce you to this study out of the Technion. This is the lab where I come from the Eisenberg lab, and Suzanne et al. Looked at how people react to tonic temporal summation. And temporal summation, as some of you may know, is regarded as the human experimental correlate of the electrophysiological wind-up phenomenon. And temporal summation is either tested by using repetitive noxious stimuli or by using a tonic noxious stimulus as this one over here. And their study was about whether or not all people react the same in a temporal way to the stimulus. In the past, they always used to look at the first peak after the temperature rises. Then there was a nadir in most people, and after the nadir, in most people, the pain ratings went up again. And in past studies, they used the 60 seconds mark as the nadir point and the 120 seconds mark as the second peak point, and that would be the temporal summation. But in their study, they wanted to see if everybody reacts the same way. So they gave everybody a tonic stimulus of 46.5 degrees for 120 seconds and used the COVAS in order to rate their pain perception. And the typical pattern, and they had quite a large group of 154 subjects, the typical pattern here on the left is the one that you see here, where we have a first peak, a nadir, and then a second peak. And then what you do is you calculate the temporal summation by subtracting the nadir from the second peak, and that's your temporal summation. But they found also that not everybody reacts the same way, and that some participants actually have a continuous ascent and do not have a first peak and nadir and then an ascent, but continuously ascend from the moment the temperature stabilizes. And in that group, you can calculate temporal summation from the highest peak to the moment the temperature stabilizes. But also in some participants, there was a first peak, and then the ratings went down and never came back up again. And these are people that actually do not have a lot of temporal summation. You could ask yourself whether this is due to a standardized temperature that they used, and maybe for these people that this is a temperature that's not noxious enough in order to provoke temporal summation. Well, I wanted to show you how I would do this study if I would do it with our devices and with the COVAS here in our office. So I took the QSense. It's a little bit of a different device than the ones they use, but definitely a device that can do tonic heat. Very nice, simple device. And I'll show you what it looks like in the software and also on my hand. So you can see that I strapped on the thermal. Everything is real. Okay, so these are also real pain ratings. Please take that into consideration. I chose the program. I go into the test. And those who are unfamiliar with our software, this is what it looks like when you run a test. The pink line is the line for the temperature. So you see that it's ascending. And now the blue line is the line for the COVAS ratings. And you can see I tried to time it as best as I could in the video. you can see that what my perfectly manicured hand is doing is rating my pain perception along with the stimulus, and you can see that it is exactly the same, and that the software is responding to each and every little change that I make with the COVAS. On the top, you can see in the middle wait, and that's the time that we still have left for this stimulus to end. And you can see that every little change in my perception is translated to the COVAS and is shown on the graph on the screen. Of course, this is not a normal situation, because in a normal situation, your participant will not see the screen, will not have access to that information, to the fact that actually the um, stimulus is a tonic stimulus and not an ever-changing stimulus. They will not know whether the stimulus intensity is changing. They will be attentive to whatever they are feeling through the thermode. So in another 30 seconds, the stimulus will be done, and then I will be able to show you how you can look at the results in an Excel sheet that you can export from our results tab in the software. So another few more seconds. You see that the pain is going up for me. I'm feeling it's constantly rising right now. And you'll see that as soon as the temperature drops, it's not painful anymore, and I'm rating it 0, and the temperature keeps dropping back to the baseline of 32 degrees. Up. It's not playing along with me. Oh, here we are. It's our Excel sheet. So let's say I exported this Excel sheet of these results to our to my desktop, and now I have different entities that I can see in my Excel sheet. You have different tabs over here at the bottom: data, description, COVAS, results. You have the timestamp. Keep in mind these are milliseconds, so you'll have a very, very, very long Excel sheet, and you probably want to translate it to seconds. You have events. You have the tech temperature. That's the temperature of the thermode. Here in description, you have the different data of the patient, what kind of paradigm it was. Here we have the timestamp again and the COVAS again, and I'm copying it and pasting it to the data sheet. And keep in mind, we have also events. These are also things that we can use. I'm taking the COVAS rating and I'm taking the temperature of the thermode. And let's put it all together in a graph. And then we can see that whatever happened during the time that there was a stimulus present. The blue line in this is the stimulus going up and staying up, and the pink orange line is my pain ratings. You have the first peak, you have a nadir, right? And then you have a second peak. You can click on them, and then you can see what the ratings were in each and every time. So there was a nadir of 0, and there was a second peak of 55. So I would say that my temporal summation is 55. And there's different ways that you can calculate these things. So this is a very nice graph, and this is a very nice tool for you to use in your data processing. Okay, so let's do a small poll and see if I explain myself well enough. What type of temporal summation do you think I have? I'm very curious to see what you think. Would this be a typical, atypical, constantly ascending temporal summation? Would be an atypical no pain increase? Or would this be a typical with a nadir and a second peak? Let's see you vote. You can vote on the panel that was just in front of you. I'm curious to see what your answers are, and we can discuss them afterwards. So, okay, there's already one vote. Anybody else caring to vote? Don't be afraid, there are no wrong answers. This is pain research. There are always interpretations. So let's reveal the surprise. Let's see what you all voted. Okay, so the two people that voted said this is a typical graph, and I would agree. Okay, so there is an nadir and there is a second peak, and then you can calculate temporal summation. So thank you very much for those who voted. We'll go back to the next slide and talk a little bit about offset analgesia. So I just want to use this study to talk about what offset analgesia is. And offset analgesia is the disproportionate large decrease in pain ratings for a small decrease in factual temperature. And I want to take you to this graph and point you to the black line, and the black line is the temperature ascent. So the temperature is going up to 49 possibly, then staying there for 5 seconds, then going up to 50, staying there for 5 seconds, and then going back to 49 degrees and staying there for another 20 seconds. And even though we were already at 49 degrees before we went up to 50, the pain ratings that we see here in blue of the healthy participant are not at all similar to those at 49 degrees here to those that we saw at 49 degrees there. So there is a disproportionately large decrease after we came back for 50 degrees. The interesting, and some say this may be some kind of paradigm to test descending endogenous analgesia. And there is quite a lot of discussions about that. And offset analgesia, I can tell you that I see more and more papers about offset analgesia, and many people are interested in measuring it, in testing it, and trying to find out what it is that we're measuring and what it is that we're seeing. What we see in this paper from quite a while ago, but still discussed, is the fact that there is a difference between healthy volunteers who have quite a lot of pain inhibition and to those that are neuropathic pain patients and for whom the pain is not disproportionately descending, right? So this is a more of an attenuated descent. And this is something to keep in mind. I want to present to you the next study by Alter from about 2 years ago. And they looked at offset analgesia, which you can see here in the middle of the graphs. And they compared it to an inverted effect. They asked themselves whether if we do it invertedly, would we also see a disproportionately large increase after that? And they compared it every time to a constant stimulus. What they used to calibrate pain 50, because they wanted to test it at pain 50, is they used the COVAS, and they did several different temperatures, and this is how they had people rate pain 50. And then when they had their pain 50, they used that temperature to do either the inverted graph, the offset analgesia, or a step down. And they compared these results that they obtained to a constant stimulus. So if the stimulus would stay the same, it would have the orange graph. But since the stimulus was like this, inverted, there was a disproportionately large increase. And in offset analgesia, there was a disproportionately large decrease, and also in the step down. And they called this disproportionately large increase an onset hyperalgesia. So this is an interesting way to look at it. And excuse me. And so this is definitely a study to remember when you want to start researching and looking at offset analgesia. I want to take you to conditioned pain modulation world. And conditioned pain modulation in very, very short. And I took a slide from a previous webinar that we did on conditioned pain modulation. I would really like to invite you to come to that webinar, because I think it's an interesting webinar. There are quite a lot of topics that's, on all different aspects of CPM, condition pain modulation, and I think it may be of interest to you. So condition pain modulation is a paradigm to test descending analgesia capacity by introducing two different noxious stimuli concurrently or sequentially, and to measure the amount of descending inhibition. And this type of phenomenon is the phenomenon that we call diffuse noxious inhibitory controls in animals. The phenomenon where you walk around with a headache, you bump your foot, and suddenly you don't feel your headache anymore, and people ascribe that to CPM. So when we do this in the lab, we don't have people walking around with a headache and bumping your feet. We actually give a controlled thermal stimulus, for instance, at 46.5 degrees, and have the participants rate it. How much does it hurt right now? Well, it hurts 60 out of 100. Then we introduce a conditioning stimulus. So this would be a noxious stimulus as well. And this noxious stimulus can be either concurrently with the second test stimulus, which is the exact same stimulus, or sequentially. So it would come before the second test stimulus. And these test stimuli should be exactly the same. And then the CPM effect is expressed either in VAS, in visual analog scale, pain decrease. And we can see here in this participant rated their pain 60 first and then 20 later. So their CPM effect is VAS minus 40. This is an effective CPM, but if their pain would stay the same or would even increase, that would be inefficient CPM. So, and we know that CPM, and why are we interested in CPM? Because we know that CPM has been shown to be less effective in patients suffering from chronic pain, but also the other way around. Those with less effective CPM are more likely to suffer chronic pain, for instance, after a traumatic event like surgery. So after this short introduction into CPM, I want to take you to the next slide, and this is on young patients, young chronic pain patients, 608 young chronic pain patients between the ages of 8 and 21. And in this study out of McGill, they looked at their CPM capacity using a tonic pain stimulus at pain intensity of 50 out of 100. And they did a tonic stimulus of 120 seconds. Then they had the patients put their hand into a cold presser of 12 degrees for 2 minutes, and then they did another 2 minutes of tonic heat stimulus. And they had their patients use the COVAS to rate their pain perception to the test pain to the tonic heat stimulus. And what we can see is that they found different patterns of CPM in this whole group. And each line in this top graph represents one patient. So we have 608 lines, I guess, in this top graphs. And we can see that about half of the patients had optimal CPM, which means effective CPM, and they calculated CPM efficacy by taking the average of the COVAS after the conditioning stimulus minus the average of the COVAS before the conditioning stimulus, and dividing it by the the average COVAS before the conditioning stimulus, and times 100%. So here we have patients who had CPM efficiency between 100% and 30% pain decrease. The suboptimal group had efficiency between 30% reduction and 10% reduction, and those who had inefficient CPM had either 10% reduction and or pain increase. And they compared this to healthy controls, age and gender matched, and they actually did not find any differences. And this is interesting to know and to think about. Maybe we could think of the fact that these are still young people. Their nervous system is still building itself, and they may be still more resilient to the effects of chronic pain they suffer from. But just an hypothesis, and I think a review of the literature of young people and CPM would be warranted and would be interesting to do. I want to take you to a different world, the world of itch. And many of you may be pain clinicians, pain researchers, so itch is not really on your radar, but maybe it should be because we know that there are parallels between itch and pain. We know that many people would prefer pain over itch, and attesting to that is the fact that we would itch so much until scratch so much until we bleed. So this is itch and pain. But we also know that, for instance, in atopic dermatitis, patients suffering from atopic dermatitis would use noxious heat shower, and this would alleviate some of their pruritus, some of their itch. So this study looked at uh, healthy people and atopic dermatitis, eczema patients, and looked at how histamine is affecting their itch sensation, but also how scratching and how uh, tonic heat is affecting their itch sensation. And they had the itch rated on the COVAS. So the COVAS in this case was not 0 to 100 in pain, but 0 to 100 in itch. And the nice thing about the outcomes of this study is that they show a definite difference between those with the healthy controls and the atopic dermatitis patients, but also a difference within the atopic dermatitis patients in the lesion skin and the non-lesion skin, and also how the scratching and how tonic heat are affecting their itch sensation. So this is really a validation of how we can use the COVAS and how sensitive it is to different states of itch. For those of you considering to research itch now or in the future, I want to ask the question whether precision outcome gives us a better repeatability. And Martin DeVita and his colleagues out of Syracuse, New York, have put together a novel quantitative sensory testing protocol that they shortened it quite a lot, and they have used our device, the QSense CPM. This is a QSense device with two thermodes. So they looked using this device at the pain threshold, at the pain tolerance, the super threshold pain, and they looked also at conditioned pain modulation using two thermodes. They looked at offset analgesia and also at tonic temporal summation. And they did this study on 33 healthy volunteers in 2 sessions, 7 days apart, and looked at the repeatability of these measures. In pain threshold and tolerance, they are using a very, very slow rate. They're using 0.3 degrees per second. And this is something that I see a lot in North America, but not a lot in Europe. But this rate can eliminate quite a lot of um, um, the uh, um, the speed of which somebody the reaction time. So the reaction time um, bias, it can eliminate quite a lot. And they actually found that pain thresholds and pain tolerance have excellent repeatability. So I think this has much to do with the fact that they used a very, very slow rate. And the super threshold pain that they used was the average between the pain threshold and the pain tolerance. Conditioned pain modulation, uh, they actually had a very, very novel um, uh, paradigm, and they used the test stimulus 30 seconds long at the super threshold pain level, so at the pain 50 level, more or less. And in the last 20 seconds, they add the conditioning stimulus of the second thermode. And this is how they did CPM and offset analgesia and temporal summation. And the offset analgesia protocol, they did, as I showed you before, and the temporal summation protocol, they did super threshold temperature at 120 seconds. And again, you see good repeatability of these measures 7 days apart. So in this case, they use the COVAS peak and the COVAS nadir, for instance, to calculate the um, the um, the CPM, and the second peak and the COVAS nadir to calculate temporal summation. So this is some food for thought. So every lab chooses a different analysis method, and they did it this way, and the lab in McGill did the average of the COVAS, and these are both possibilities that you can use when you use the COVAS. I want to expose you to one of the programs that we have in our software, and that is the patient controlled intensity in the search program. And this is a novel way of looking at pain and having the patient control the temperature. So you can, for instance, tell the patient, I want you start a stimulus and say after 10 seconds, I want you to stay at this pain level. You can use the lever to control the temperature. And then the patient can use the lever to do that. And I just want to show you how it looks like in our software, but also what it looks like on our COVAS. So this is, by the way, a good way to search our database. In this, we are using the COVAS as a search device, but you can also use the response unit, by the way. We're having a destination temperature of 40, a destination rate of 5, and a search rate of 2. So mind you, the search rate here is important, and we want it to be low. And I'll explain to you in a second why we want it to be like that. And we said that we want to be at the destination for 60 seconds. Let's go to the test in a second. Yes. To start off the program, we need our COVAS device to be exactly in the middle. Oh, I'm strapping it on, so everything is real, okay? Every data, every pain rating, everything is real. I did it on myself. So I'm strapping the thermode on, and now I get the prompt. You need to have the COVAS in the middle. You can look at the bottom where my mouse is right now in the yellow, and the COVAS needs to be on 50. So I'm moving the lever until I see 50 on my screen. This is where we should start the test. I'm clicking OK. I'm starting the test. Again. And here we go. So the temperature has gone up. That's the pink part. When I move my lever to the right, this temperature goes up. When I move it back to the middle, in the middle, the temperature is staying steady. When I move the temperature down, the lever down, now I'm moving it up again. So now the temperature will go up again. And I'm moving it to the middle, steadies it out. If I move it to the left, it goes down. The further I move it away from the middle, the faster it goes. So the search rate is the rate that the maximum rate that it will go, the furthest I have it from the middle in our COVAS. Okay, so keep that in mind. If you do a very, very long, high temperature, so you say, I want a search rate, I want a search rate of 10 degrees per second, this would be this may startle your patient because suddenly the temperature goes up and they feel that they don't have control over it. So I would do a low search rate, a low rate with which the temperature goes up and down, and have the patient move the lever as they feel their pain. In the patient controlled intensity, so this is the search program, it can be either heat or cold. Okay, and it can be also non-pain. You can say, I want you to be at the same temperature intensity, not necessarily pain. Because we are a medical device company, because we take care of the safety of our users, the temperature versus duration safety limitations apply. So we will not have the program pass these limitations and get and get an unfortunate situation, we will, and this is why you would always start your search program at a specific temperature that's not too high, so you have leeway to go up or down. This program is available for the TSA2 Air, the TSA2, and the Pathway. Uh, with regard to the COVAS, it will start from the middle, as I showed you, and the middle would also be no temperature change. The temperature increase will be to the right, and the temperature decrease will be to the left. And the distance traveled from the middle, so the further we go from the middle, the speed of the temperature change increases. We have come to almost the last part of our webinar. The data processing, we can always export it to Excel. I would recommend you to use standard or temperature events. You can use averaging, but you can also use peak and nadir. And in a second, I want to show you what these events are that I'm talking about. So these are standard events, what you see here. And on the left, this is the way we use our program. So this is the way to program what we want to do. And here I said I want to have several several plateaus, ramp and holds going up and down. And I want to have the event at the onset. So this is this little star, that's the onset when the temperature will start to go up. The destination is when the temperature has reached the destination that we sent it to. The end of duration is the end of the destination, and the end of the trial is this little star. And this will allow you, because we have like this huge Excel sheet with in milliseconds, this will allow you to search easily where the patient was at and using these markers, these events. What you can also do, for instance, when you use the search program, you want to say, oh, I'm interested to know how much of the time the patient was above a specific temperature. So let's say, in this case, I'm sending the thermode up to 45 degrees, but I want to see how much of the time was spent above 41 degrees or 44.5 degrees. So I want to see what was going on around the destination. And then I say, okay, I want at 41 degrees, I want an event, and I want the directionality to be up, and that would be this blue dot. That's this event. When the temperature goes up and passes the 41 degrees, it will put in an event. And when the temperature goes down and passes the 41 degrees again, I said, okay, I wanted the directionality to be down, and then we have this event. So these are events that can help you in your data analysis and to find specific spots in your paradigm and what was happening to the patient at that moment. To summarize, the COVAS will offer you high temporal resolution to pain ratings, and this is instant and this is continuous. And this is very interesting for fast phasic stimuli, but also for long tonic stimuli. Of course, you keep in mind this is a computerized visitor analog scale. Your participants will see it on the scale. They don't have to translate it to numbers. They don't have to verbalize it. They just have to move the lever. This will mean something with regard to your patient-examiner interaction, and this can reduce some noise maybe from your studies of things that you cannot really control. For instance, your patient and your examiner's gender and their interaction and their chemistry. It will the COVAS will allow you several options of data analysis, and it fits pain and itch, but it also may be other sensations that you can think of, and the sky's the limit, and I'll let you decide what you would want to use the COVAS for. At last, I would like to thank you for participating, and if we will not be in touch, wish you very happy holidays around the world. And this is the time to ask your questions in the Q&A panel if you have them, and I'll try my best to answer them to the best of my abilities. I'll stop sharing, and I'll go to the Q&A. Okay, so this is an interesting question. Thank you, Marek, for asking this question. You asked whether you think the COVAS can be used for clinical or for research. I think for both. I think that the VITA study definitely is a study that's very much aimed at clinical use. I know that there is clinical use with the COVAS. For instance, in Canada, the study that I showed you out of McGill, these are patients that have undergone also QST in their rehabilitation trajectory for chronic pain. And there's a nice study that came out this year by Okai. I hope that I'm pronouncing it correctly, from 2022, in which they share the results and their clinical decision making based on their CPM, for instance, CPM and temporal summation data that they have on these young patients. And this, I think, this is an amazing study. And if you leave me your email, I'll be happy to share that the full text of that publication with you. So I think this is both a clinical and a research tool. And if for clinical, of course, keep in mind there is a little bit of a way that you need to do to look at the study at the results. But of course, this is always the case when doing CPM and we're doing temporal summation. This is not just doing limits for sensation and pain thresholds. This is just a little bit more complicated, but pain is complicated, and those who are pain clinicians know that and use the devices to make their decisions. So I think it's not a big jump from clinical use. A very interesting question by you, Masha. Thank you very much. You're asking, can the COVAS be used with my Algomed device? Unfortunately, not currently. This is not something that we heard about a lot. Usually, people use the Algomed for thresholds, for doing pressure pain thresholds, doing pressure pain tolerance. We hear very little of using, for instance, a tonic stimulus with the Algomed. I've actually, I don't remember seeing any studies using a tonic stimulus with the Algomed. But if we would hear from our customer base that this is something that they definitely need to have working together, please have those feedback come in, and we can definitely consider having that in the future. Any other participants that would like to ask questions? Thank you, Mark, for leaving me your email. I'll definitely share the Okai study with you regarding clinical use of CPM, temporal summation, and using the COVAS to go along with that. Definitely. Can your new, Alice, thank you very much for your question. Can your new software work with the older TSA and COVAS? Yes, the Medoc Main Station software is designed to work with the previous TSA, the one that we saw, the one that looks like a briefcase, and the COVAS. So those can work together, and you can definitely contact your distributor regarding getting a newer software version. The MMS works with the with the older TSA type and the COVAS as well. So so definitely yes. Are there any more questions? I think you guys, I want to congratulate you on the many interesting and important questions that you asked. Sometimes there are no questions, but this time you quite had interesting questions for me. So thank you for also sharing that with the other participants, because it's always interesting to know what others are asking and learn from them. If there are no more questions, I'll give you another minute or so to ask your question and see what's going on with that. If there are no more questions, I would like to say goodbye for now and meet you on another occasion. Again, maybe in the flesh, but if not, maybe in our next webinars. Thank you very, very much for joining. Happy holidays, and hope to see you again. Thank you very much.